Okay, so we are done with confusion matrix, and we found a way by which we can have kappa separately, accuracy separately. So let's go back to our script, and let's do the same thing with another package called IRR. The reason why I want to have that package is because it's very useful when you're writing functions to evaluate the effectiveness of your model in, say, cross validation, where you have to run the same model 10 times, and you will take the mean or the average of your kappa statistics or average of accuracy. So IRR is great for that, and we'll see one function where I utilize that. So install the package IRR. Now I'm calling the library. So the library has been called. Now I'll use a function called kappa2, which is part of IRR, and it requires a data frame that has two columns in there. One is called the default, the actual default, and what we predicted. So we know that they are off by 24, but that is what we need. And based on that data frame, kappa2 will calculate the kappa statistics and few more things, but we are only interested into the value of the kappa. So this dollar over here implies only give me the value that comes out of kappa2 function and put that into a variable called kappa. So let's enter this thing, and now kappa is calculated. Look at the kappa 43.1, which is not a surprise because that's exactly the number we have over here for kappa, which we got from confusion matrix. So this is another way of doing that. Now let's do another thing called ROCR package, which is used for plotting ROC curve. So I'm installing that package. Package is installed. Let's call the library ROCR. So I call the library. Okay. Now, in order for our ROCR package to work, there are two things that we need. The first one is called prediction, how our probability is doing versus the actual prediction. And then we need another thing called performance. And performance is nothing but, as we know about ROC, it's nothing but a plot between false positive rate and true positive rate. How much of false positive rate we have to sacrifice in order to gain some true positive rate. So let's do ROC curve. The first thing we have to do is to create this prediction variable. The function is prediction. It takes two things. The first one is prediction, which is nothing but the probabilities of yes that we calculate in the previous step in data frame called credit underscore result. So what is the probability of yes? Is it 20%? Is it 30%, 90%, 95%? And for that 95% or 30%, 20%, what is the actual result? Was that really yes or no? So this is the actual yes and no. So we hit that, and now we have created our variable called predict, which has all the predictions in there. Okay, so here we got all the predictions, yes and no, actual yes and no's, and their respective probabilities in terms of yes. And then we have to create a performance variable, and for that the function name is performance. It takes the prediction variable that we created in the previous step and then two more things. What is on the y-axis? It's going to be the TPR, true positive rate, as we saw in the class, and on the x-axis it's going to be the false positive rate. So that is FPR, and let's hit enter. So now we got prediction and performance. All we have to do is to plot this in our ROC curve. So for plotting, we have a function called plot, and we'll plot our performance, which has on y-axis TPR, on the x-axis FPR. The name or the title of the graph going to be ROC curve for the credit default. The color of the line going to be blue, and the width of the line going to be 2. So let's hit enter, and we got our ROC curve. Now, one thing that we're missing is a line in the middle that tells us that if we do a random assignments, there is no model whatsoever. That's what we're going to get, a line at 45 degrees. So here we have a function called AB line. All it's doing is plotting a regression line, which has an intercept of 0. So the first part, A is equal to 0, implies intercept is 0. B is equal to 1 implies the slope of this line will be 1. That implies for every movement in false positive rate of, say, from 0 to 0.2, y will also move from 0 to 0.2. So that is what this 1 implies. And with that slope, all we're going to get is a line going from here because the intercept is 0. So this line going to go through 0 by 0 from here, and it will be at 45 degrees crossing over here. Its width gonna be of um, weight 2, and the line type will be 2. So it is a dash line is 2. If we make it 1, then it'll be a different line. So now we get a straight line.